All right, guys, so this is the Math 1050 midterm review number 2, okay? Question number 1, list all the possible roots. Okay, so your constant is 3, so what goes into 3? 1 and 3. Your leading coefficient is a 2. What goes into 2? 1 and 2. So you go 1 over 1 is 1. 1 over 2 is 1/2. 3 over 1 is a 3. 3 over 2 is 3 over 2. Make sure you put parentheses around it. Put a plus or minus in front of it. Highlight that answer so I know that that's the one that you're saying. And that's it. Okay. Question 2. Which one of these is a rational root? Okay. So you just store those in your calculator and then you plug them in. And then one that works out, the one that gives you a 0 is the answer. So if you go -1, store, enter. 3, membar, enter, raise it to the third. Plus 14, membar, enter, x squared. Minus 47, membar, enter. Plus 14, enter. You don't get a 0. Then do the same thing for -2/3. Although it's way faster, so go -2 divided by 3, store, enter, up, enter, and you do not get a 0. Move to the 1/3, so 1 divided by 3, store, enter, up, enter, and you get a 0, so your answer is x equals 1/3. Okay, question number 3, given that that is a 0 or a root, find the remaining. So put a 2 right there. Across the top, exponents are 3, 2, 1 constant, so you're not missing anything. So 1, -2, -5, 10. 1 comes down. 1 times 2 is 2. -2 and 2 is a 0. 0 times 2 is a 0. A -5 and 0 is a -5. And -5 times 2 is a -10. And you should get a 0 right there. So I began with an x to the third. I did synthetic once. So this is an x to the second. So this is x to the second plus 0x minus 5 equals 0. The 5 comes over. X squared equals 5. Square root it. I get x equals plus or minus the square root of 5. Highlight my answer and I'm done. You guys, you can totally check this. So just go second x squared 5, store, enter. And then put it into that equation, you should get a 0. Same thing with the negative square root of 5. Okay? Question number 4. A polynomial with real coefficients has this as a 0. What's another 0? So this is a little tricky because you have to write it in the form of a plus bi. So they gave you x equals 3i minus 2. So that's actually the wrong order. So it's a -2 plus 3i. So therefore, the conjugate is also a solution, so the answer is -2 minus 3i. So what my students did when this was their final is they took that and they changed the sign of the 2. So the 3i and the 2 were both positive in their answer. That's actually wrong. They should both be negative. So make sure you put it in the right order and then do the conjugate. Okay? Okay, so question 5. F plus g of 2. That means find f of 2 and add g of 2. So go across where the x value is a 2. The f of x is a 5. And then g of x is a 3. So 5 plus 3 is 8. Question 6. The absolute value of x minus 2 equals 1. So you have x minus 2 equals 1 or x minus 2 equals -1. Move the 2 over, x equals 3. Move this 2 over, x equals 1. You can totally check your answer. Put in the 3. 3 minus 2 is a 1. Absolute value of 1 is a 1. Put in a 1. 1 minus 2 is a -1. Absolute value of -1 is a +1. Okay, number 7. Find the solutions in interval notation. So it's the absolute value of x is greater than 4. Step 1, isolate the absolute value, done. Step 2, make it an equal sign. Step 3, split it apart and solve. There's nothing to solve. Go to your number line. My circles will be open. because I don't have an equal sign. Exaggerate that. This is a greater than, so you automatically know to shade the outside. If it's an absolute value inequality, you just look at that. You don't do signs. So in interval form, the answer is negative infinity to negative 4 with a parenthesis, union 4 to infinity. Please make sure you highlight all your answers or box them so there's no question what you're saying the answer is, okay? Question 8. So you have one domain that x cannot be 2, another domain that it has to be greater than or equal to 1. Okay, so when you do these problems, you guys, I would totally graph those. So this is 1 and bigger, but it can't be a 2. So right here at 2, you actually have an open circle, okay? So if you're writing this in set notation, you would say x such that, and then I would say 1 is less than or equal to x is less than 2, or x is greater than 2, like that. So I said between those two, parentheses on the 2, or bigger than 2, okay? That's your answer, and you're done. Question number 9, write the difference quotient, but don't simplify it. Okay, so here is your equation. Here is your difference quotient, okay? So f of x plus h is one step. A separate step is subtract the original, and a third and separate step is to divide by h. So I'm going to go x to the second minus 3x plus 1. But see those x's? That's my original. But see those x's? I'm not going to write them as x's anymore. I'm going to write them as x plus h. So it looks like this. Then I subtract all of f of x. That's probably the biggest mistake that people make right there. And then it's all over h. Sometimes you'll see like brackets here and there. It's totally not necessary. That doesn't do any good to put brackets there, so I never do. Okay, so that's your answer right here. Okay, question number 10. Which of these is a correct first step? Okay, so remember these are the weird ones. You've seen it a little bit. So they want you to simplify this, and what they want you to do is to rationalize the numerator. So you multiply the top and the bottom by the conjugate of the top. So it's the exact same thing that's on the top, except for to put a plus in the center. So it looks like that, and your answer is A. Okay, number 11. So they give you f of x, and I'm going to write the non-factored version, and I'm also going to write the factored version. Okay, so it goes like this. This is x and x. 3 and 2 multiply to give me 6 and add to give me 5, so it looks like that. So question 11, find the domain that comes from the bottom. So x can't be a negative 2, nor can it be a negative 3. Okay, question 12. To find the x-intercepts, you let y be 0, which is the same as letting the top be a 0, and that gives me a negative 3/2. You have to write that in as an ordered pair, or they won't give you anything. Question 13, find the y-intercept. You let x be a 0. So if I look here, and I let x be a 0, I get 3/6, which reduces to 1/2. Done. Okay, so up above, same kind of thing, but they have given you a different equation. So here's your equation. So I'm going to factor it. So it goes to an x and an x, and a 2 and a 1, and they're both positive. And on the bottom, you have x plus 3. So the vertical asymptote on number 14 comes from the bottom, and you get x equals negative 3. Question number 15. The non-vertical asymptote is biggest over biggest if it's a horizontal. So x squared over x tells me that the horizontal asymptote is none, and we have an oblique. So now I'm going to go x plus 3 divided into x to the second plus x plus 2. What do I multiply by x to get x to the second? That's an x. Distribute, I get x to the second plus 3x. Change my signs. Those cancel. Negative 2x, and bring down the 2. What do I multiply by x to get a negative 2x? That's a negative 2. Distribute negative 2x minus 6. Change my signs. Those cancel. I get an 8. That's the remainder, and I throw it out. And so I get y equals x minus 2. Okay? Question 16. Consider this. Find the x-intercepts. So you're going to let y be 0, which basically means take that thing that they gave you and set it equal to 0. So that gives you a negative 4, 0. That gives you a 3, 0. And that gives you a 2, 0. And that's it. Okay, question 17. Consider this polynomial, which best describes the end behavior. Okay, so if you look at the exponents, you guys, here's your original problem. Remember, when it's all multiplied out, you have to add those exponents. So this guy gives you an x squared. This guy gives you an x. This guy gives you an x squared. When you add those together, you get an x to the 5th. There's no negative in front, so it takes on the shape of the cubic. So your end behavior is left down and right up. So if you look at that, which one's left down and right up? That would be option B. Number 18, this equation represents the height of a ball in meters, t seconds after it was thrown. So your x is your t, and that stands for seconds, and your y is your eighths of t, and that stands for height, and that is in meters. Okay, how many seconds does it read at maximum? The seconds is the x coordinate. So they're just asking for negative b over 2a. So that's negative 4 over 2 times negative 1. And that gives you a 2. Make sure that you label it. Okay. Question 19, which describes a correct first step. So this is a critical numbers type 2. Critical numbers type 2, step 1 is to get a 0 on the right hand side. So I'm just going to pull that over, and there's my step 1, and that would be option C. Okay, the others are not correct. Okay, number 20. So basically on this problem, they've started to factor it for you. So the original problem is x to the second minus 4x plus 3 over x plus 2. And they factored it, basically giving you critical numbers. So the top factors to 3 and 1, signs are the same, they're both negative. You have an x plus 2. Lots and lots and lots of you are forgetting to write that less than or equal to 0, so make sure you do that. Critical numbers from the top are 1 and 3. From the bottom's a negative 2. Keep in mind that x cannot be a negative 2. So come over here and go to a negative 2. Come over here to a positive 3. The 1 is closer to the 3 than it is the negative 2. I'm going to have an open circle on the negative 2 and closed on those ones right there. This is the one where you have to test your regions. The 0 is here. So if I test a 0 in this multiplied out version, I get a 3 over 2, which is a positive. I know my signs are going to alternate because all of these exponents, once it's factored, are all 1s. So it's going to be negative, positive, and I'm looking for less than, which would be negative. So that's here and here. So my answer is negative infinity to negative 2 with a parenthesis, union 1 with a bracket to 3 with a bracket. Please make sure you highlight your answer and do not forget the U. Okay, number 21, which is the correct first step. So these correct first step ones are really so nice. So the 2 comes over and becomes a negative. So I have the absolute value of x minus 1 is greater than or equal to 5. The next step is turn it into an equal sign. The next step is to split it. Some of you are not remembering to write it as an equal sign. So be careful. 1 comes over, you get x equals 6. 1 comes over, you get x equals negative 4. Then you go to a number line, negative 4 on the left, 6 on the right. You have an equal sign, so they're going to be closed. If it's an absolute value inequality, you look there. No signs, you just know greater than means outside. So in interval form, it's negative infinity to negative 4 with a bracket, union 6 to infinity. Highlight your answer and you're done. Okay, 22. solve this. This is a critical numbers type 1. So step 1, pull the 1 over x over. It becomes a negative. Step 2, get a common denominator, which is going to be an x. Some of you are just dropping the denominator. You cannot do that. So that 2x does not have the x. And so 2x times x is 2x squared. The negative 1 does not have the x, so it's minus x. This guy does have the x, so it's minus 1. Then I factor. So 2x a second goes to a 2x and a plain x. The 1 goes to 1 and 1. Signs are different. Biggest is a negative, looks like that. Critical numbers from the top are x equals negative 1/2 and 1. From the bottom is a 0. I don't have to worry about restrictions because there's no equal sign anyway. So a 1 goes here. The 0 is closer to the negative 1/2 than it is the 1. They're all opened. Exaggerate that they're opened. The 0 region is here. If I test 0, I actually can't test 0. That was an accident because it's a critical number. So I'm going to test. You can test anything you want. I'm going to test over here. I'm going to test a positive 2. So if x is a 2 here, then it's 2 times 4, because 2 squared is 4, minus 2 minus 1 over 2. So that would give you 8 minus 2 minus 1 over 2. So that gives you 5 over 2, which would be a positive. I know my signs are going to alternate. It's going to look like that. So I would just store a number in if I were you, but I don't have a calculator in front of me, so that's why I did that. Greater than means positive, so that would be here and here. So my final answer is negative 1/2 to 0 with a parenthesis, union 1 to infinity. Highlight my answer, and I'm done. Okay, here's 23. Okay, so 23, here's your original problem. I'm going to have a multiplied out version right there in front of me, but I'm also going to have a factored version. So this goes to 3 and 2, signs are different, biggest is the negative, okay? Now you have to remember that you need to find the x-intercept, the y-intercept, vertical asymptote, non-vertical asymptote, and does it cross. So to find the x-intercept, you let y be 0, which is the same as letting the top be a 0, and you get negative 3, 0. To find the y-intercept, you let x be a 0, goes away, goes away, goes away, 3 over negative 6, that's a negative 1/2. Vertical asymptotes, this negative 3, 0, by the way, crosses because this exponent is a 1. Vertical asymptotes come from the bottom. X equals negative 2, and it's odd because your exponent's a 1. X equals 3, and it's an odd because your exponent's a 1. Non-vertical asymptote, that's biggest over biggest. Look at the multiplied out version. That's x over x squared. The bottom's bigger, so it's y equals 0. Does it cross? Set the right side of the non-vertical equal to the right side of the multiplied out version. Cross multiply, and you get x plus 3 equals 0. Move your 3 over, x equals negative 3. So does it cross? Yes. Where does it? When x is a negative 3. If you look throughout this, you can see that the x-intercept is negative 3, 0, and that's where it's going to cross. Okay, let's graph this. So negative 2 and positive 3 are your vertical asymptotes, and they are both odd. So I would write odd right there. Y equals 0. Some people panic because it's going across the x-axis. Who cares? Just extend it. Don't just put it right on there, and don't put it above. Just extend it. Okay, so negative 3, 0 is the x-intercept. That's where it's crossing my non-vertical, and it crosses right there. The y-intercept is 0, negative 1/2, so it's about right there. And that's it. Okay, so I can't tell the right, nor can I tell the left, but I can tell the center, because there's no way it's going to be up high because I've got to get to that intercept right there. And the only way to get there is to touch the x-axis, and I cannot touch the x-axis. So therefore I know it's not up, it's got to be down. So this is going to be down like this, come over and hit it, okay? And now I'm there. How do I know if I A, swing up, or B, swing down? Well, if I swing up, I hit the x-axis again, and I cannot touch the x-axis anywhere except -3, 0, so I know I have to be down. So now this is like playing Sudoku, and you've got some of the numbers figured out. So this asymptote is odd, and I'm down on the right, so I have to be up on the left. So it goes like this, it's going to come down, it's going to peak down a little bit, and come back up. This is down over here, this asymptote is odd, so this guy's got to be up, it's going to come over, and it's going to swing like that. You guys, after I figured it out, what the graph looks like, and after I'm done with my test, I think I'd come back over and I would like put in a 4 and see what that y value is, and I would make sure that it's accurate. Then I do a 5 and like a 3.5, and you know, I would just test some points and get a really accurate answer. Okay, all right guys, here's 24. So solve this. So step number 1, get it alone. So you have the absolute value of 2 minus x is greater than 7. Step number 2, make it an equal sign. Step number 3, split it apart. And when you split it, that's when you drop those absolute value symbols. The 2 comes over, negative x equals 5. Change your signs, x equals -5. Over here, 2 comes over and becomes a negative. Change your signs, x equals 9. -5 over here, 9 over here. I don't have an equal sign, so they're going to be open. I do not have to test my regions. This is an absolute value with an inequality, so I know automatically greater than means outside. So my answer is -infinity to -5 with a parenthesis. Union 9 to infinity. Close your parenthesis. There's your answer. Highlight it. Done. Okay, number 25. So here's your equation. And they tell you what is the maximum revenue. Well, I can't do -b over 2a to that because that's a line. So they tell you that revenue is x times p. So just make sure if you read what is the maximum and you don't have a quadratic, meaning an x squared, or in this case a p squared, you have to change the equation. So this is x, which is 1,000 minus p times p. So 2 seconds, I'm going to get a drink. So when you do that, you're going to get a p squared, and then once you have a p squared, you can do the -b over 2a. So when you distribute this, you get a -p squared plus 1,000p. Keep in mind that the x is the p, which probably stands for the price, yep. And that y is the r, which stands for the revenue. And they want to know the maximum revenue, so they want to know the maximum y. So I'm going to go -b over 2a, and I'm looking here. So that's -1,000 over 2 times -1, which is 500. That's the maximum price. That's the price that will give you the maximum revenue, I mean. So I'm going to go -500 squared plus 1,000 times 500. I put that in my calculator, and I get 250,000. That's a revenue, which is dollars, and you're done. Okay, 26, and we are done. Okay. Okay, graph it. They say make sure that you label the x-intercepts, the y-intercepts, and the end behavior. So guys, this is an x to the first, this is an x to the second, this is an x to the first. Add them up and you get an x to the fourth. There's no negative, so it's going to open up. So my end behavior is left up, right up. X-intercepts, you let y be 0, which basically means take that thing right there and set it equal to 0. So then you have 2, 0 crossing because it's a 1. -3, 0 bouncing because it's a 2. -5, 0 crossing because it's a 1. To find the y-intercept, you let x be a 0. So you go back to this thing being a y, and you put in a 0. So again, I don't have a calculator, so I'm just going to go 0 minus 2, 0 plus 3 squared, 0 plus 5. That's a -2 times 9 times 5, which is a big, huge number, -90, I believe. So 0, -90. Okay, so now we're going to go like this. And that's kind of crazy. 9 times 5, yeah, it's correct. Because they actually give you a scale. They go by 30s, but still. 9 times 2, or 3 squared is 9. 9 times 5 is 45. Yeah, so we're good. So I'm just not even going to worry about a scale. So I'm going to go like this. So I've got 2, 0 crossing, -3, 0 bouncing, -5, 0 crossing, and I'm going to go up and cross through, and I'm going to come down and I'm going to bounce, and you know it's going to go really low, then it's going to come up and it's going to cross through. And then I think that scale they gave you is horrible. So what I would do is I would just come over here, I would extend that guy, I'd put a point right there, and I'd call it 0, -90. I'd call this 2, 0. I'd call this -3, 0. This is -5, 0. They want you to label all those things. I think that's totally sufficient. Okay. I know it's not to scale, obviously. This far right here is not going to be 90, but it's too big. So that's totally sufficient. Okay, that's it, guys. Go to bed early tonight, please.